In this video, we are going to solve a problem for a point source at complex plus simple elevated terrain. Here screen view model runs twice, first for complex terrain inputs and second for simple elevated terrain inputs. As we already know that in simple terrain, screen view calculates 1 hour concentration estimates, and in complex terrains the model provides 24-hour concentration estimates. However, we can convert 1 hour estimates to other averaging periods, that is 3 hour, 8 hour, 24 hour and annual, by using the appropriate multiplying factor as shown here. We just remember here at this juncture of this video that for converting 1 hour concentration to 24 hours, we have to multiply it with 0.4. Now what is our problem for today? Consider a single air pollutant emitting stack located on a complex plus simple elevated terrain in a rural area. The point source has the following parameters. The pollutant emission rate is 100 gram per second, stack height 100 meter, stack inside diameter is 2.5 meter, stack gas exit velocity is 25 meter per second, stack gas exit temperature is 450 Kelvin and ambient air temperature is 293 Kelvin. And the complex terrain information is given, that is at the distance from the source 5 kilometer, the stack height is 175, and distance from source is 7 kilometer, 8 kilometer, 7 or 10 kilometer, that is 7 to 10 kilometers. The terrain height is 200 meter. As we know that for complex terrain height must be more than the stack height. And the automated distance option is that at stack height is from the terrain height from the stack base is 30 meter, then the minimum distance is 50 and maximum distance is 1 kilometer. That is from 50 meter to 1 kilometer. The terrain height is 30 meter. From 1 kilometer to 3 kilometer it is 70. From 3 kilometer to 5 kilometer it is 90 meter, and from 5 kilometer to 10 kilometer terrain height is 100 meter. And as we know, for the elevated terrain, that the terrain height must be less than or equal to the stack height. Now what we have to calculate? We have to calculate the maximum pollutant concentration for complex terrain for 24-hour concentration, and the maximum pollutant concentration for complex terrain and maximum pollutant concentration for simple terrain is in 1 hour concentration. Now this is my screen view. I am opening my project already created. You can create your project by hitting new here and incorporate the information as given. So I open my project, and the source type is point, dispersion coefficient rural, flag pole receptor is 0 meter, and I incorporate the point source parameters as given in the problem. Now I hit next. Terrain option is complex plus simple terrain. Simple terrain is elevated terrain. Automated distance is selected. full meteorology is selected, non-regulated options brought to mixing height no, anemometer height is default, that is 10 meter. Now I hit next button. Complex terrain, I incorporated the value as given in the problem by selecting this add button one by one. I just hit add. You can see that a new row is coming. So now I delete this cell, this row, by hitting delete. It has been already deleted, so we need not to do anything, just hit no. From this terrain height viewer, you can see here that at 5 kilometer the terrain height is 175, and from 7 kilometer to 10 kilometer from the source terrain height is 200 meter. And in case of automated distances, I have incorporated the information as per the problem, and if you hit this terrain height viewer, you can see here that from 30 to 100 meter, from 50 to 100 meter terrain height is 30, and accordingly for terrain height 17 it is 1 kilometer to 3 kilometer accordingly. Now the distance is none, so I hit next, downwash, nothing to do anything, hit next, and then fumigation, you have nothing to do anything. Once I hit next, this window is appeared, project is complete, I hit run, and this run finished successfully. I hit graphs, put change point to line. So this graph is complex terrain versus concentration. You can see here that from 5 kilometer to 10 kilometer distance from the source, the concentration is gradually decreasing. And for automated distance, four graphs is created. This is for 30 meter terrain height. You can see the changes. In case of 70 meter, you can see that the concentration is nearly 195 to 100, and for 90 meter distance from 3 kilometer to 5 kilometer is 120 to 150, and for 100 meter terrain height 5 kilometer to 10, the concentration ranges from 200 to 180 microgram per meter cube. If you see this output, you can see that for complex terrain the 24-hour concentration is given for each of 4 height of 2 height for 4 distance, and maximum is given. And in case of simple terrain, you can find that terrain height of 30 meter, the information is given of every 100 meter array, and the maximum concentration is given for this particular case. In case of terrain height of 70 meter, from 100 meter to 1 kilometer to 3 kilometer, every 100 meter array is given and maximum concentration is given. Similarly for 90 meter and for 100 meter, and this is of 500 meter 500 meter array, that is 3 kilometer to 10 kilometer. And overall you can see that for simple terrain, maximum concentration is 202.9 microgram per meter cube at terrain height 100, and the distance from the source is 5.5 kilometer. And for complex terrain, the concentration is 86.13 at 500 meter distance from the source, and this at terrain height is 175. But this concentration is 1 hour concentration, and for complex terrain concentration is 24-hour concentration. So this will be our answer, that the maximum concentration for simple terrain is 202.9 microgram per meter cube at a distance of 5,532 meter when the terrain height is 100. And similarly for complex terrain. Now if we convert this 1 hour concentration to 24-hour concentration, we have to multiply this 202.9 into 0.4, and the result will be the 81.16, so which is similar at this distance and for terrain height. So thank you for watching this video, and for more details you can see my video link here, and there in this video in the different pages there's so many documents are given as reference, so you read this document for better understanding.